So today we're going to be finishing up the 9-1, like I said, 9-1A. The first part was just talking about the translations. All right, so that was it, just the left, right, up, down, stretch, compress, reflect. That's all the first part was. All right, so this part, we're going to talk about some other things, specifically zeros, max, and mins.
Oh, they're new notes?
Yeah, they're new notes. They're up here on the table.
Why did we do the beginning of the 9-1?
It was just the parent function. Yeah. The translations was the main part there. All right. So for the zeros here, on number 1, it is already factored out for me, right? Everything's in parentheses. So it's super easy to get the zeros when it's already factored. It's just like when we did the quadratics, where you set all your factors equal to 0. So I have x minus 2 equals 0, x plus 1 equals 0, and x plus 3 equals 0. You all remember doing that? Right, with the quadratics?
Yeah.
All right. Same thing with cubics. There's just more of them. So everything's factored. I take my factors, equal them to 0. So my first 0 is going to be at x equals what? At 2. My second one will be at x equals. And then my next one will be at, good. So my zeros are at 2, -1, and -3. When I'm talking about the graph, the zeros are the same thing as what?
Oh,
the x-intercepts. So I know I'm crossing the x-axis at 2, -1, and -3. Okay, we are going to be doing the rest of this in the calculator. We're not going to do the max and mins without a calculator. So in my calculator, I am going to graph this x minus 2, x plus 1.
Did you put it in how it was the first?
Yes. And put it in just like this. So x minus 2 in parentheses, x plus 1 in parentheses, and x plus 3 in parentheses. Hit enter. And so, I mean, you should cross the x-axis at 2, -1, and -3, right, because that's my 0. And now we just need to figure out where my relative max and my relative min points are. Now, we haven't heard the word relative yet. Huh?
Does it change the meaning?
No. And so, the reason why it's called a relative is because, technically, yes, this point right here is a maximum, right? But is it the highest point your graph will go to?
No.
That's why it's relative, because it's relative to the area around it. Does that make sense? It's still a maximum. It doesn't change anything, but it's just relative to a certain area, because this graph will technically go up for forever. I don't know. There's lots of sirens, though. Okay. Menu, analyze the graph, and we're still going to do maximum. And I'm just going to highlight this maximum here. Make sure you don't highlight too much, because remember, it is relative to that area. So we're just going to highlight this guy right here till my little black dot points at the top. Hold on one second. I'll come check yours. It might just be your window, maybe. Oh, you didn't put okay, so do you see how this x and then that's a -2, not -2? So this guy here needs to be -2. Yes. All right, so I have my maximum. Now I'm going to do my minimum. So my minimum point is down here, right? It's kind of off the graph, but in the calculator, as long as you highlight where it would be, like I highlight right here because I know it's going to be down here, your calculator will automatically zoom for you. So press enter. It automatically zooms, and it gives me my min point at 0.786, -8.21.
So, correct, we're just doing the ones that go with that. The max and the min from the ones that actually curve.
Yeah.
Not the line.
Right. No, not the forever stuff. On your graph, it doesn't have to be exact. I know that my max will go up here to about 4-ish, and I know my min will be down here at -8. So it doesn't have to be exact. But sketch it as best you can. Okay. Any questions on that first one? Sweet. All right. Number 2, same thing. It's not factored though, so I'm going to do the whole thing in the calculator. Okay, so I'm going to find the zeros and everything in the calculator. And I'm just going to type it in just like I see it. So x cubed, and then I have plus 3x squared minus x minus 3. Hit enter. And it pops up. I'm going to zoom in a little. All right. It just so happened where my max and my min are already popped up because of what I did previously in the other problem, so I just got lucky there. But if not, you'd have to do it again. In this case, I don't have to. This point right here, this guy, is that the max or the min? Max. And then what's this guy down here? The min. All right, so my max is at -2.15, 3.08. And my min is at 0.115, -3.08. All right, my zeros are where it crosses the x-axis, so I'm going to go to menu, analyze my graph. Which one of these guys do you think I will pick? 1, the 0, right? Because I want to find the zeros. And I'm just going to start highlighting where my zeros are. So my first 0 is 1. And then if I keep scrolling, my black dot should move. My next 0 is at -1. And then keep scrolling. Ooh, there it goes, -3. All right, so on my graph down here, I know I'm crossing at 1, -1, and -3. And I'm going up to about 3 for my max and my min. Positive 3.08 for max and then -3.08 for min. And that's it. All right, so a lot of using the calculator, finding your zeros, max, and mins on those first couple. All right, so we good on those? Sweet. All right, go down to finding the multiplicity. All right, so then this next bar says finding the multiplicity of a 0. So if a linear factor of a polynomial, so we're talking about like the solutions, the zeros. So if the solutions are zeros, if they're repeated, or sorry, the factor, if the factor is repeated, then the 0 or solution is repeated. Right. So if the factor is repeated, then the 0 or solution is repeated. And a repeated 0 is known as a multiplicity. Multiplicity is the number of times a 0 occurs. It's not always possible to tell the multiplicity of a 0 from a graph. So it is not always possible. Which means that we have to do it by hand with algebra by factoring. All right, so you cannot do this one in the calculator with the graph. Put a little star. Multiplicity. Say multiplicity. Good job. Multiplicity is going to be the exponent. All right, so we're going to tell the multiplicity from the exponent. It's actually not that hard. All right, flip it over. So that's what we're doing here on 4 through 7. So we're looking at our factors, because your factors will tell you the zeros, right? So what's this, one of my zeros on number 4?
1.
X equals 1. What's this one going to give me? -3 And what's this one going to give me? -1. Now, which one of these zeros has an exponent on the factor? The third one, right? -1 has a square right here. So what that square means is that x plus 1 times x plus 1, right? It's happening twice. So what you would say is x equals -1 has a multiplicity of 2 because the exponent of a 2. So the exponent just tells you how many times it's being repeated, and -1 is being repeated twice because there's an exponent of a 2. Does that make sense?
Yeah.
Okay.
So basically the back
Yeah.
is that it?
Yep, that's all I have to do. So number 6, once again, I got to find the zeros first. So what is the zero that is given by just a plain old x? What's the solution? Like, where is it going to cross the x-axis? Say that again. 0. There's no number there. It's 0. So if there's a plain old x, it's going to cross the x-axis at 0, which means it's going through the origin. Does that make sense? So plain old x's, you get a solution of 0. Like 0 is actually one of your answers. What is that solution going to be? 6. Does that have a multiplicity? Of what? 2. So you would say multiplicity of 2. And then what about this guy? -2. Does that one have a multiplicity? No. Drop down to 7. Any questions so far? Okay. All right, number 7. This x right here, what's that solution? 0. Does it have a multiplicity on the x? No, there's no exponent on the x. Oh, yeah, I'm sorry, I skipped 5. 5 would have a multiplicity. And then what is that factor? What's that 0 going to be? -2 with a multiplicity of what? Good, of 4. I'm actually going to change 5. I don't like it. We're going to change it. X squared plus 4x plus 4. The reason why I want to change it is because there's 2 of these on your practice, and people are kind of getting stuck on them. So change it to not be factored. All right, number 5. So on number 5, it's not factored. And remember, the graph does not always tell me the multiplicity. So I have to do the x method and factor this one. So what 2 numbers multiply to give me 4, but add to give me 4? 2 and 2. So I can open up my factors, x plus 2 and x plus 2. Or you can write it as x plus 2 squared because they happen twice. Okay. So once you factor it, then you can do your solutions and all of that good stuff. So what is my solution on this one? Close. At -2, yeah. -2 with a multiplicity of 2. Good. Does that make sense? All right, awesome. Drop down to the last part here. All right, this last part, we are going to just go backwards. So I give you the solutions, the zeros, and you are going to write it as a polynomial function. So we're putting it back into the factors. All right, so on number 8, if I were to put -2 back into a factor, it would be x plus 2. And if I were to put 3 back into the factor, it would be minus 3. And then if I were to put 1 back into the factor, it would be x minus 1.
Why does it have a square in
It's just different ways of writing it. So these are still my zeros. So still my zeros here. So if I were to put -3 in a factor, it would look like what? X plus 3. What if I were to put 0 in a factor? just an x. Normally you do see that out in front, but the order does not matter of these guys. But you do normally see the plain old x's out in the front. And then what about the 2? X minus 2. All right. And then there is one other thing about these problems. It says to write it in standard form. So standard form means we need to multiply everything out. So it's a lot of just multiplying. You could either FOIL or do the box method, right? Like distributing, or do the box method if you like the box. I like distributing these guys. So because there are 3 things that we need to multiply, I'm going to just ignore one of them. All right, I'm going to ignore one, and I'm going to multiply these 2 guys together first. So what is x times x? What is x times negative 2? Okay. Then I'm going to multiply the 3 out. So 3 times x. And 3 times negative 2. Good. Don't forget to combine your insides. It makes your life way easier. So I have x squared plus x minus 6. After I multiply those 2 guys together. And then, yeah, and so we still have this x on the outside. And so the last thing you have to do is take that x. Let's multiply that in. So x times x squared, x times x, and x times negative 6. Good. And so then that's your guy in standard form. All right, let's finish out this number 8 here, put it in standard form, and then I'll be done. All right, so same thing. We're going to ignore this first factor here. We're going to multiply these 2. So x times x, x squared, x times negative 1, negative x. And now we're going to take the negative 3. So negative 3 times x, minus 3x. Negative 3 times negative 1, plus 3. And please, 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 combine like terms so your life doesn't get harder than it is. Negative x minus 3x minus 4x. All right, but we still have this factor out here in front. All right, so it's just a lot of multiplying. First, I'm going to take the x and multiply that. So x times x squared, x cubed. X times negative 4x,
minus 4x squared.
Good. And x times 3,
Plus 3x.
Good. And now, let's see what color. Orange. I'm going to take the 2. And I kind of like to line up my like terms because it helps me, I guess, add them up. You don't have to line them up. You can just keep writing it if you want. But 2 times x squared.
Plus 2x squared.
2x squared. So I'm going to put it right underneath here, this 2x squared. All right, 2 times negative 4x.
Minus 8x.
Minus 8x. So it's going to come right under here. The 8, the other x. And then last one, 2 times 3. Plus 6. So when I combine all my like terms, which I have lined up, my x cubed gets brought down. Negative 4 plus 2.
Minus 2x squared.
3 minus 8.
Minus 5x.
And then the plus 6. And so now it's in standard form.
Oh, I love that.
Any questions?